Okay, so now our next topic is mean value theorems. Now this mean value theorem basically gives us a relation in terms of a given function and its derivative. Okay, so there are basically four different mean value theorems. The first one is Rolle's mean value theorem. So this theorem says that if y equals to fx is a function defined in this closed interval ab, okay, third bracket means these two boundary points are included. So if we have a function defined in this closed interval ab such that, and the function is satisfying these three conditions. The first one is fx is continuous in this closed interval ab, meaning that in this interval a to b there is no break in the graph of this function y equals to fx. Second condition, fx is differentiable. Differentiable means the curve is smooth, so differentiable in open interval ab. And the third point is f of a is equal to f of b. Okay, so if these three conditions are satisfied, continuous in closed interval ab, differentiable in open interval ab, and f of a is equal to f of b. So if all these three conditions are satisfied, then the theorem says that there must be at least one point c in this interval a to b such that f dash c will be 0. So this is the statement of Rolle's theorem. If all the three conditions are satisfied, we have a continuous and differentiable function and f of a is equal to f of b, then there must be at least one point. Now the meaning of this word at least is there will be minimum of 1 point. Okay, it is possible that there might be more than 1 point for which this equation is satisfied, but there has to be at least 1 point for which this f dash c will be 0, where c is a point lying in this interval a to b. Okay, so now we are going to see the geometrical meaning of this Rolle's theorem. So geometrical explanation is that suppose if we have a function y equals to f of x, okay, and there are 2 points a and b, there are two values of x, a and b, such that f of a is equal to f of b. So suppose if this point, this height is f of a, so this means coordinate of this point will be x coordinate a, y coordinate f of a, and say this point is b. Since f of a is equal to f of b, these two heights are same. This point is b, x coordinate b, y coordinate f of b. Okay, so now this f dash c is nothing but slope. We know that first derivative is slope of tangent line. So f dash c will be slope of tangent at some point c. Okay, and we also know that if slope of a line is 0, then that line must be parallel to x-axis. Okay, if you have a line which is parallel to x-axis, then for that line the slope will be 0. So this theorem says that there will be at least one point c, okay, whatever be the graph of this function y equals to f of x, there has to be at least one point c where the tangent line will be parallel to x-axis, because f dash c is slope of tangent, and if slope of tangent is 0, then the line must be parallel to x-axis. Okay, so for example, you can draw a curve something like this. Say this is your graph of y equals to f of x. So the theorem says that there will be at least one point x equals to c where the tangent line will be parallel to x-axis. Here f dash c will be, for this line f dash c will be 0. Okay, you can draw any other curve. Suppose if I have a curve, say something like this. Now what will happen? At these two particular points, the tangent line will be parallel to x-axis. So no matter which curve you draw, if the curve is continuous and smooth, means if there is no break in the curve and the graph of that function is smooth, then there will be at least one point where the tangent line will be parallel to x-axis. There might be more than one point where tangent will be parallel to x-axis. So that is the geometrical explanation of Rolle's theorem. If all these three conditions are satisfied, there has to be at least one point between a and b where the tangent line will be parallel to x-axis. So now we'll take one problem on this Rolle's theorem. In fact, we'll take two problems. Okay, so our first question will be based on whether this Rolle's theorem is applicable or not for a given function, and the second problem will be to find the value of this c if the Rolle's theorem is applicable. Okay, so first question that we are going to take is discuss applicability of Rolle's theorem, meaning that whether this theorem can be applied or not. Discuss applicability of Rolle's theorem for fx equals to mod of x square minus 3x plus 2 in this interval 0 to 3. Okay, so this is the problem that we have. This will be our first problem, and we will take one more problem that will be based on finding the value of c for a given function in a given interval. So find c, this will be our second problem. Find c of Rolle's theorem for fx equals to x cube minus 4x in this interval minus 2 to plus 2. Okay, so these two problems we are going to see. So the first one is we have to discuss whether the theorem is applicable here or not. So our fx is x cube minus 3x plus 2. The theorem will be applicable only when all the three conditions are satisfied. So here if you see the graph of this particular function, okay, these are your coordinate axes. Now this thing you can write as x minus 1 into x minus 2. So fx will give us 0, 1 when x is 1 and other when x is 2. So, and you can see that you have x square here. So we all know that quadratic expression in x is an equation of parabola, and okay, remember that this equation ax square plus bx plus c, this will always represent a parabola. If a is positive, then it means this will be an upward parabola, and if a is negative, this means this will be a downward parabola. So here, since coefficient of x square is positive, it will be an upward parabola. So and this parabola will give us 0 value at these 2 points. So you will get a curve something like this. This will be your graph of y equals to x cube, not x cube, x square minus 3x plus 2. This will be the graph of the function y equals to x square minus 3x plus 2. Now if we have to take the modulus of this function, then erase the portion of graph which is below x-axis and then take its image in x-axis. So you will get a graph something like this. Okay, this is now your graph of y equals to mod of x square minus 3x plus 2. Okay, this graph. So, and we had to check the applicability of this function between 0 and 3. So this point will be x equals to 0 and this point will be x equals to 3. Right? Now between 0 and 3, you can see that this function is not differentiable. Okay, here at these 2 points we are getting corner point. So this means the function is not differentiable at these 2 points. Okay, so since fx is not differentiable, fx is not differentiable at x equals to 1 and x equals to 2. Okay, therefore Rolle's theorem is not applicable here. Rolle's theorem is not applicable. Okay, remember that other two conditions are satisfied here. If you want to check, you can verify this, that this is a continuous function, right? This is always continuous function. First condition was fx should be continuous in AB. So we had three conditions: continuous in AB, differentiable in AB, f of a is equal to f of b. So first condition is satisfied, right? Function is continuous. Second condition is not satisfied. Okay, you can see that at 1 and 3, at 1 and 2, these 2 points are between 0 and 3, and at these 2 points the function is not differentiable. And the third condition, f of a, so f of a means f of 0, this will be 2. F of b means f of 3, this will be mod 3 square minus 3 into 3 plus 2, which is 2. So f of a is equal to f of b. Okay, f of 0 is equal to f of 3, and this is 2. So this means the third condition is also satisfied. But since the second condition is not satisfied, therefore Rolle's theorem is not applicable for the given function in the given interval. So this was our first problem. The second one is find the value of c for Rolle's theorem for the given function. Now for this problem we don't have to check whether the conditions are satisfied or not, because only if conditions are satisfied then some value of c will be possible. Okay, so but if you want to verify, you can verify. Fx is x cube minus 4x. Okay, while solving the problem we can directly start with f dash c equals to 0 and find the value of c from here, because the question is we have to find the value of c for Rolle's theorem. So if the condition was satisfied, only then this question will be valid. But if we want to check the conditions, then you can easily see that fx is a polynomial function, so this will be always continuous, right? Second one, fx is polynomial, again always differentiable. So fx is both continuous and differentiable. The third condition was f of a will be f of minus 2 cube minus 4 into minus 2, this will give us 0. F of plus 2, this will be 2 cube minus 4 into 2, this is again 0. So f of a is equal to f of b. So all the three conditions are satisfied. So since all the three conditions are satisfied, there has to be at least one point between minus 2 to plus 2 where f dash x will be 0. So if I differentiate this, then I will get f dash x equals to 3x square minus 4. If I equate this to 0, okay, maybe I can write f dash c equals to 0, this will give us 3c square minus 4 equals to 0. C will be c square will be 4 by root 3. So value of c will be plus 2 by root 3 and minus 2 by root 3. Now as you can see that both of these values are lying between minus 2 to plus 2. Okay, 2 by root 3 is less than 2, minus 2 by root 3 is greater than minus 2. So clearly there are two values of c for which Rolle's theorem is satisfied. So as I explained earlier, the theorem is there has to be at least one point. It is possible that there might be more than one point. Okay, for this particular example, there are two different values of c for which f dash c will be 0 for the given function in the given interval. Okay, so this was all about Rolle's theorem. Next we have to learn Lagrange's mean value theorem. Okay, so our next theorem is Lagrange's mean value theorem. Now here the statement is, if y equals to fx be any function defined in this closed interval ab such that fx is continuous in closed interval ab and differentiable in open interval ab. These were the first two conditions of Rolle's theorem. Okay, here the third condition of Rolle's theorem is not applicable. F of a equals to f of b, that condition is not here. We have only first two conditions of Rolle's theorem. So now the theorem says that if these two conditions are satisfied, then there must be at least one point c in this interval a to b such that f dash c will be f of b minus f of a by b minus a. Okay, if these two conditions are satisfied, you have a continuous function in closed interval ab, differentiable in open interval ab, then there must be at least one point where f dash c will be f of b minus f of a by b minus a. Now again we are going to see what is the graphical meaning of this thing. So now suppose if we have, say this point is x equals to a, here the y coordinate is f of a, here we have x equals to b, y coordinate is f of b, and since f of b and f of a may be different numbers, so therefore we have taken different height, we have taken general case. Now if you see carefully, this right hand side is nothing but slope of line AB. Okay, slope of this line AB will be difference of y coordinates, so f of b minus f of a by b minus a, right? This is slope of line AB, and this left hand side is slope of tangent at any point C. Right, f dash c, first derivative is slope of tangent. If we are calculating first derivative at some point c, this is nothing but slope of tangent line at that particular point. And if slope of two lines are equal, we all know that if slope of line 1 is equal to slope of line 2, this means line 1 is parallel to line 2. Right, if the slope of two lines are same, then it means those two lines must be parallel. So you can say that the graphical meaning or geometrical meaning of this Lagrange's mean value theorem will be that if we have a function for which these two conditions are satisfied, then there must be at least one point where the slope of tangent line will be equal to slope of line AB, meaning that the tangent will be parallel to this line AB. Okay, so suppose if I draw a graph like this, say this is your graph of the function y equals to f of x. So as you can see that if I draw a tangent line at this particular point, then this tangent line is parallel to these two lines. Okay, this is your tangent line, so this tangent line is parallel to this line AB, right? So this is the meaning of this Lagrange's mean value theorem, that no matter which graph you draw, there will be at least one point where the tangent to this function at that particular point will be parallel to this chord AB. Okay, so this is your x equals to c. This is the point where the tangent line is parallel to x-axis. And from this theorem you can also see that if you use the condition of Rolle's theorem, the third statement of Rolle's theorem was f of a equals to f of b. Now if f of a equals to f of b, then from here you can see that this f dash a will be 0. So Rolle's theorem is nothing but one special case of Lagrange's mean value theorem where f of a and f of b are same. Okay, this is general formula and Rolle's theorem can be derived from here. But those two theorems were developed independently. So this was all about Lagrange's mean value theorem. Now we'll take one problem on this Lagrange's mean value theorem and then we'll move to our next mean value theorem. Okay, so now we have this one problem on Lagrange's mean value theorem which was asked in GATE 2014. So the problem is this LMBT is satisfied for the function fx equals to x cube plus 5x in the interval 1 to 4 at a value of x equals to. So here our fx is x to the power 5, x cube plus 5x. Okay, now this fx is a polynomial function, right? And we know that polynomial function is always continuous and differentiable. So here the first condition, fx is continuous in AB, is satisfied. The second condition, fx is differentiable, is also satisfied because polynomial function is always continuous and differentiable. So it is also continuous in this interval 1 to 4. So now the question is, there has to be at least one point where f dash c, this will be f of b minus f of a by b minus a. Now using this formula we need to find the value of c. If this is your f of x, then you can easily see that f dash x will be 3x square plus 5. This will be the first derivative. So now we are going to find the value of this c. So f dash c will be 3c square plus 5 and this will be f of b minus f of a. So if this is f of x, if I place b equals to 4 here, then I will get 4 cube plus 5 into 4 minus f of a. So now if I place x equals to 1 here, then I will get 1 cube plus 5 into 1 and this divided by b minus a, so 4 minus 1. So from here I will get 3c square plus 5. This will be 4 cube plus 5 into 4. So this is going to give us 64 plus 20, 84. 84 minus 6. So this will be 78 by 3. So 78 by 3 is 26. Okay, so 3c square plus 5, this will be 26. This means 3c square will be 21, c square will be 7. The value of c that we are going to get is minus root 7 and plus root 7. Now the theorem says that the point has to be between 1 and 4. So you can see that this minus root 7 is outside the given interval, root 7 is in this interval 1 to 4. So correct answer here will be c equals to root 7. Okay, root 7 is nothing but 2.645 I guess. Okay, so this will be the value of our given problem. This will be the answer to our given problem. Now next we have to learn Cauchy mean value theorem. Okay, so now our third mean value theorem is Cauchy mean value theorem. So here the formula is, if fx and gx are two functions defined in some closed interval ab such that they are continuous in closed interval ab and differentiable in open interval ab. Okay, so remember that first two theorems, Rolle's theorem and Lagrange's mean value theorem, were for single function fx, whereas this Cauchy mean value theorem is for two functions fx and gx. If both of these functions are continuous in some interval, closed interval ab, and both of these functions are differentiable in some open interval ab, then the theorem says that there must be at least one point c in this open interval ab such that f dash c by g dash c, this will be f of b minus f of a by g of b minus g of a. So this theorem is called Cauchy mean value theorem. Now with the help of one problem, we'll see how to find the value of this c for given function f and g. Okay, so our problem is find the value of c for Cauchy mean value theorem. Here fx is e to the power x and gx is e to the power minus x. Now without doing any calculation, simply by recalling the graph of these two functions, you can say that both of these functions are continuous and differentiable, right? This was our graph of the function e to the power x. So you can see that this is a continuous graph and there is no sharp change in the graph. The given curve is a smooth curve, therefore it is also differentiable. And e to the power minus x, okay, this will be a decreasing function because it is 1 by e to the power x. Base less than 1 means exponential will be decreasing. So both of these functions, e to the power x and e to the power minus x, are both continuous and differentiable. So we can directly start with our Cauchy mean value theorem. The problem is we have to find the value of this c. So the value of c will be obtained using this relation f dash c by z dash c. This will be f of b minus f of a by z of b minus z of a. Also, if this is fx, then f dash x is also e to the power x, and from here z dash x will be minus e to the power minus x, right? So now using this formula we are going to find the value of c, for which Cauchy mean value theorem is satisfied. So f dash c will be e to the power c, z dash c is minus e to the power minus c, f of b e to the power b minus e to the power a, z of b e to the power minus b minus e to the power minus a. So now we have to simplify this equation to get the value of c. So I can write this as minus e to the power 2c, and this will be e to the power b minus e to the power a by 1 by e to the power b, 1 by e to the power a. So from here you can see that you will get minus e to the power 2c, e to the power b minus e to the power a, this divided by, if I take the product of these two as LCM, e to the power b into e to the power a, then I will get e to the power a minus e to the power b. So this will give us minus e to the power 2c, and you can see that if I take minus sign common here, I will get plus here, minus here, these two will cancel. So this will give us minus e to the power a plus b. So this means e to the power 2c is e to the power a plus b. If base is same, we can equate the exponent. So we will get c equals to a plus b by 2. And we all know that a plus b by 2 is nothing but arithmetic mean of these two numbers. So this has to lie between a and b. Okay. So for the given problem, the value of c, for which Cauchy mean value theorem is satisfied, is a plus b by 2. So this will be the answer to our given problem. Okay, next we have to learn about this Maclaurin's formula. So first, the idea behind this Maclaurin's formula is that any non-algebraic function can be expressed in the form of a polynomial function. Okay, using this Maclaurin's formula, whether you have any trigonometric function or exponential function or logarithmic function, any function can be expressed in the form of a polynomial function using this Maclaurin's formula. So first let us see what is the formula, then we'll see the significance of all those things. So the formula is, if fx is a differentiable function, differentiable any number of times, okay, then fx can be written in this form. Fx will be f0, f0 means value of function at x equals to 0, plus x into f dash 0. Okay, f dash 0 is first derivative at x equals to 0, plus x square by 2 factorial, second derivative at 0, plus x cube by 3 factorial, third derivative at 0, and this will continue up to infinity. So this is a very, very important formula. This formula is called Maclaurin's formula. Okay, and using this formula you can write any function f of x as some polynomial function. See how we are getting polynomial, because this is some constant, x into some constant, x square, f dash 0 by 2 factorial is some constant. So you will get only positive integral power of x, x to the power 1, x square, x cube and so on, or you will get x to the power 0 here. So this was the definition of polynomial, right? That the exponent of x should be non-negative integer. So here we are getting that. So therefore you can write any function in the form of a polynomial function using this formula. And why in the form of polynomial function? Because many times it is much easy to differentiate or integrate a polynomial function compared to any other function. Okay, so This is the idea behind this Maclaurin's formula. Now we'll take one example and we'll see how to use this formula. Suppose if fx is cos x and we want to write this cos x in the form of polynomial in x. So for that we will need these values, f of 0, f dash 0, second derivative at 0 and so on. So if fx is cos x, this means f of 0 will be cos 0 is 1. If I calculate the first derivative, we'll need all these terms, first derivative at 0, second derivative at 0 and so on. So f dash x will be minus sin x, f dash 0 will be minus sin 0, which is 0. Okay. Second derivative will be second derivative of cos x. So minus sin x minus cos x. Second derivative at 0 will be minus 1. Similarly, the third derivative will be f triple dash x. This will be sin x. Derivative of minus cos x is plus sin x. Third derivative at 0 is 0. Fourth derivative will be derivative of sin is cos x. The value of cos x at x equals to 0 is 1. So as you can see that this pattern will repeat. You will get 1, 0, then again minus 1, 0. Then again you will get 1, 0, then again minus 1 and minus 1, 0 and so on. So you will get 1, 0, minus 1, 0, again 1, 0 and so on. So now we are going to substitute these values in this formula. Okay. So fx is cos x, f0 is 1, f dash 0 is 0, second derivative at 0 is minus 1 and so on. So if you do that substitution, then you will find that cos x will be 1. This term will become 0, so you will get minus x square by 2 factorial, because second derivative at 0 is minus 1. This will give us 0, and the next term was x to the power 4 by 4 factorial. Similarly, you will get x to the power 6 by 6 factorial. This will continue up to infinity. Okay, so this is expansion of cos x. Cos x is 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial and so on. And you can see that you can make two very interesting observations from here. One is that we all know cos 0 is 1. So you can see that if I place x equals to 0 on left hand side, from right hand side I will get 1 only. Okay, these terms will give us 0. Second one, we all know that cos x is even function because cos of minus x is cos x. And you can see that from right hand side also, if you replace x by minus x, you will get the same expression because we have only even power of x. Okay, so this is the expansion of cos x. Now we are going to see what is the meaning of this expansion. So suppose if these are our coordinate axis, this line is x axis and this is our y axis. So we all know the graph of cos x. The graph of cos x will be a curve symmetric to y axis because it is an even function. Now if you see the terms on right hand side, okay, if you take only first two terms, if you are taking only these first two terms, then you will get y equals to 1 minus x square by 2. Now if you see the graph of this function, this will be a downward parabola, something like this. Okay, it will start from here. This will be your graph of function y equals to 1 minus x square by 2 factorial. Now as you can see that these two graphs are exactly overlapping when x is very close to 0. Okay, when x is close to 0, then you can see that the value of cos x is exactly same as 1 minus x square by 2 from this point A up to B. Okay, suppose if I add one more term here, say if I add the next term 1 minus x square by 2 factorial plus x to the power 4 by 4, let me write this thing here. Suppose if I add one more term here, 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial. Now if you see the graph of this particular function, if I add one more term here, x to the power 4 by 4 factorial, then you can see that graph will be something like this. Okay, this will be your graph of the function y equals to 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial. Now these two graphs are exactly overlapping from this point A dash up to this point B dash. Okay, so when x is anywhere between a dash b dash, then the value of cos x will be exactly same as 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial. So the idea is that as you keep on adding more and more term, this polynomial on right hand side will exactly overlap with the graph of y equals to cos x in the vicinity of origin. Okay, as you keep on adding more and more term, the range of value of x for which these two graphs are overlapping will increase. Okay, if you see the graph of, say, if I add one more term here, then maybe these two graphs will overlap from here up to, say, this point. Okay, so as you keep on adding more and more term, these two graphs will exactly match. So this is the idea behind this Maclaurin's formula, that you can write any function as a polynomial function. Now there are some other important expansion that you need to know. All those expansions are derived using this formula only. So the first one was cos x is 1 minus x square by 2 factorial. Now there are 5 other important results which are derived from this Maclaurin's formula only, which you have to remember. So the second one is expansion of sin x. The expansion of sin x is x minus x cube by 3 plus x to the power 5 by 5 factorial, x to the power 7 by 7 factorial. This will continue up to infinity. Now again you can see that sin 0 is 0. So this expansion is starting from x. Another sin x is odd function. So you are having only odd power of x. If you replace x by minus x, okay, in the first one we knew that cos minus x is cos x. Therefore we had only even power of x. Sin minus x is minus sin x. So therefore we have only odd power of x. So this was second formula. The third one that you need to know is expansion of e to the power x. Now this is very easy, because if fx is e to the power x, then f0 will be 1, f dash 0 will be 1, second derivative at 0 will be 1. So from here you will get 1 plus x square by 2 factorial, x cube by 3 factorial up to infinity. The fourth formula is expansion of e to the power minus x. Simply replace x by minus x and you will get the required formula. So x cube by 3 factorial, so on. You will get one minus sign with all the odd power of x and a plus sign for even power of x. Then the last two formula that we need to know is expansion of log 1 plus x. So this is x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4 up to infinity. Remember that first four formula are valid for all x, whereas this fifth formula is valid only when x is from minus 1 to plus 1. Okay, and the last one is expansion of log 1 minus x. Remember that in all the first four formula you have factorials in denominator, whereas in the formula of log 1 plus x you don't have factorial. You have simply these numbers 2, 3, 4 and so on. And the last formula that you need to know is expansion of log 1 minus x. So here if you replace x by minus x, then you will get the required formula. So this will be minus x square by 2 minus x cube by 3 minus x to the power 4 by 4 up to infinity. And this is again valid when x is from minus 1 to plus 1, equality at minus 1. Okay, I am having equality at plus 1 here because if I take plus 1 this will give us 2, and in the second case also we are having equality here. We are not having equality at minus 1 because then it will become log 0, which is not defined. And here also if I take equality at plus 1, then it will give us log 0. So these are 6 very important formula. You have to remember each one of these 6 formula. So this was all about Maclaurin's formula. Next we have to talk about Taylor series. So the formula for Taylor series is similar to the formula. The formula for Taylor series you can easily remember if you know the formula of Maclaurin series. Okay, in case of Taylor series the formula will be, this was our Maclaurin series. So now the formula for Taylor series will be, we have to replace 0 by a and x by x minus a. This Taylor series is used for expansion at x equals to a. Okay, this formula was used for expansion at origin. Okay, so so this is general formula. Taylor series is general formula. and if you place a equals to 0, then you will get this Maclaurin's formula. This one was Maclaurin's formula, and this was used for expansion at x equals to 0. This was used for expansion at origin, so x equals to 0. Now if I want this Taylor series from here, replace 0 by a and x by x minus a. So I will get fx equals to f of a plus x minus a into f dash a plus x minus a square by 2 factorial, second derivative at a, x minus a cube by 3 factorial, third derivative at a, and this will continue up to infinity. So this formula is called Taylor's formula. And here if you place a equals to 0, then you will get this Maclaurin's formula. Okay, so you need to remember these two formula. Now we'll take some problems based on these two formula. Okay, so now we have these two problems. This first one was Taylor's formula. This was used for expansion at x equals to a. This was our formula. F of x is f of a, x minus a, f dash a, x minus a square by 2 factorial, second derivative at a, and so on. And Maclaurin's formula was, if I place a equals to 0, then you will get this Maclaurin's formula. This was used for expansion at x equals to 0. Okay, so now the first question is based on this Taylor series. Taylor series expansion of this function at x equals to pi is, okay, so now here see the options are given in this manner. Option A is 1 plus, option B is 1 minus, option C is minus 1 plus, option D is minus 1 minus. Okay, so in GATE proper options were given. Here in order to save space I have written in this manner. So now suppose if fx is this sin x, so first we need to write the expansion of this sin x at x equals to pi, and then we have to divide that expression by x minus pi. So if I want to write the expansion of this sin x, then we will need these value f of a, f dash a, and so on. So if fx is sin x, this means f of a, this will be f of pi, this will be sin pi, which is 0. F dash x will be derivative of sin is cos, f dash pi, this will be cos pi, which is minus 1. Then we need second derivative at pi. Derivative of cos will be minus sin, second derivative at pi will be minus sin pi, which is 0. Then we will need the third derivative at pi, so this will be minus cos x. Third derivative at pi, this will be minus cos pi, which is plus 1. So now you will get this pattern: 0 minus 1, 0 plus 1, again 0 minus 1, and so on. So now you can write this sin x as, okay, using that formula you can write this sin x as in place of f of a you will have 0, so you will get 0 here, plus in place of f dash a you will have this minus 1. So x minus a, this means x minus pi, f dash a is minus 1. Now again second derivative at a, second derivative at pi, this will be 0, so I'll get 0 here. Then next term will be x minus pi. Okay, here you have x minus pi square. If you want to write, you can write this thing, that this will be x minus pi square by 2 factorial, second derivative at a, x minus pi cube by 3 factorial, third derivative at a. Now third derivative at pi will be plus 1, so on up to infinity. Okay, so now this thing can be written as minus x minus pi plus x minus pi cube by 3 factorial. If you want to write the next term will be minus x minus pi to the power 5 by 5 factorial up to infinity. Right, you will get this pattern: minus plus, again minus plus, all the odd powers of x minus pi raised to the power, all the odd powers of x minus pi, 1, then 3, then 5, next one will be 7. So now sin x by x minus pi, this will be, if I divide each one of these terms by x minus pi, I will get minus 1, x minus pi square by 3 factorial, minus up to infinity. Okay, since option we have only up to x minus pi square, so we are not writing the next term. So as you can see that the correct option will be minus 1 plus x minus pi square by 3 factorial. So this was our option C. Option D was with minus sign. So our correct answer will be this option C, minus 1 minus x minus pi square by 3 factorial. Okay, so this was based on Taylor series. Now the next question is, this is from GATE 2014. So the problem is the Taylor series expansion of this function, but no point is given. So if nothing is mentioned, then it means you need to write Taylor series expansion at x equals to 0, which is nothing but this Maclaurin series. Okay, so here we have seen the standard formula for sin x and cos x. So 3 sin x plus 2 cos x, this will be 3 into expansion of sin x was x minus x cube by 3 factorial, x to the power 5 by 5 factorial up to infinity, plus 2 into expansion of cos was 1 minus x square by 2 factorial, x to the power 4 by 4 factorial up to infinity. Okay, so now we can, if you want to rearrange this term, then you will get constant 2 from here, 3x from here, then minus x square, 2 and 2 will cancel, minus x square, factorial 3 means 6, 3 by 6 is 2, so minus x cube by 2, then we'll get x to the power 4, but we don't need that x to the power 4, options are up to x cube only, so we'll have this expansion up to infinity. So as you can see that the correct option will be 2 plus, this plus sign is option A, minus sign option B, here also plus sign option C, and with minus sign you have option D. So correct answer will be 2 plus 3x minus x square minus x cube by 2. So this is our option A. Okay, so this was a very simple problem. You had to know the formula of sin x and cos x, and then you can easily solve this problem. We will take some more problem on this Taylor series and Maclaurin series. Okay, so next we have to see these two problems based on Taylor series. So the first one is from GATE 2017. The question is the Taylor series expansion of fx equals to e to the power x plus x square around x equals to 0 is. Now we know that Taylor series expansion at x equals to 0 is nothing but Maclaurin series. So and here this problem is very simple because we all know the expansion of e to the power x, right? Expansion of e to the power x was 1 plus x square by 2 factorial, x cube by 3 factorial, x to the power 4 by 4 factorial. This will continue up to infinity. So now we need to write the expansion of this function e to the power x plus x square. So we can simply replace this x by x plus x square in this formula. So I'll get 1 plus x square plus, now if I replace x by x plus x square, I will get a square of x plus x square by 2 factorial. Similarly here I will get cube of x plus x square by 3 factorial. This will continue up to infinity. Now from the options you can see that all the options are up to x cube only. So this means we have to write this expansion only up to x cube. So if I get a term whose degree is more than 3, okay, if I get terms like x to the power 4, x to the power 5, then we will neglect those terms because we need expansion only up to x cube. So I can write this as 1 plus x square 1 by 2 factorial. So this will give us 1 by 2. Here we are going to use the formula of a plus b square. So I'll get a square plus 2ab plus b square. Now b square will be x to the power 4. So we don't need to write x to the power 4 here. Now next one, 1 by 3 factorial means 1 by 3 into 2 into 1. So 1 by 6. And here we are going to use the formula of a plus b whole cube. So I will get x cube here. And you can see that all the other terms will have power more than 3. Okay, if I use 3 a square b, then I will get x to the power 4. If I use 3ab square, then we will get x to the power 5 and so on. So we have to write only x cube from here. Now if you rearrange these terms, then you will get 1 plus x square by 2 plus x square. So this will give us 3 by 2 x square plus these two will cancel, x cube plus 1 by 6 x cube. So 7 by 6 x cube So this will be, obviously it will have many more terms, but we have to write only up to x cube. So as you can see that the correct answer is this option C, 1 plus x plus 3 by 2 x square plus 7 by 6 x cube. So this was very simple problem. Once you know the formula of e to the power x, you can easily find the formula for e to the power x plus x square simply by replacing x by x plus x square. So this was the first problem. The second one is, this is an interesting problem, and before attempting this problem we need to know one concept from class 12. This is used for differentiation under integration sign. Okay, if you have some integral and you want to find the derivative of that definite integral, then we need this formula. This formula is also called Leibniz rule. This is used for differentiation under integration. So the formula here is that suppose if I have some function of x, okay, suppose if I have ft dt and the limit are from hx to gx, so obviously this y will be some function of x, because first we have to integrate this function of f of t and then the limits are function of x. So in place of t we have to write this function of x. So ultimately you will get some function of x from here. Now the question is how to find the derivative of this function of x without calculating the integral. Okay, so here the formula will be dy by dx. This will be, first replace this t by upper limit g of x. So you will get f of g of x and then multiply this term by derivative of upper limit. So the derivative of upper limit will be z dash x minus, now replace this t by lower limit, so you will get f of h of x and then multiply this term by derivative of this lower limit, so this will give us h dash x. So this is again a very important formula. So now once we know the formula, let me give you an example how to apply this formula. Suppose if you have, say, y equals to sin x plus cos x, okay, integration of, or maybe I can call this sin t plus cos t dt, and the limit is, say, from x square to x cube. Okay, suppose if this is some function of y that we have, and if I want to find the derivative of this function, if I want to calculate this dy by dt without evaluating this integral, okay, because here it is easy to integrate this thing, but many times you will find that it is not easy to integrate these functions, and we only need the derivative of y with respect to x. Y is some function of x, so we need dy by dx. So using this formula you can directly find the derivative without calculating the integral. Let me show you how. First replace this t by upper limit x square. Okay, so replace all the t, so you will get sin x cube. Okay, here we have x cube, so sin x cube plus cos x cube, and then multiply this term by derivative of upper limit. So derivative of upper limit will be 3x square minus, now replace this t by lower limit, so lower limit is x square, so sin x square plus cos x square, and then multiply this second term by derivative of lower limit. So derivative of lower limit will be 2x. So this will be the derivative of y with respect to x. First replace all t with upper limit and then multiply that term by derivative of upper limit minus replace all the t by lower limit and then multiply this term by derivative of lower limit. So this formula is used for differentiation under integration sign without evaluating the integral. One more thing, whenever one of these two limits is constant, then you will have only one term. The reason is that suppose if I have some constant here, then derivative of constant will be 0, so this second term will vanish and you will only get one term here. So now we are going to see how to solve that problem using this formula that we have just learned. You can see that there fx is e to the power minus t square by 2, integral of that function. Now it is not easy to integrate that particular function, so here fx is integration 0 to x e to the power minus t square by 2 dt. Okay, and this fx is written as a0 plus a1x plus a2x square. The question is, what is the value of this coefficient of x square? Okay, we have to find this a2 here. So the first step will be, see, the formula for fx was f0, okay, expansion around x equals to 0. So this was Maclaurin's formula. So fx was f0 plus x into f dash 0 plus x square by 2 factorial, second derivative at 0 up to infinity. Okay, so if you compare these two, this is the given expansion and this is the standard formula. So if you compare these two, then you can easily see that a2 is nothing but second derivative at 0 divided by 2 factorial, right? a2 is coefficient of x square. So here the coefficient of x square is second factorial at 0, sorry, second derivative at 0 divided by 2 factorial. So this will be the value of a2. So in order to calculate a2, first we need to find the second derivative of this function, and then in place of x we have to substitute 0. So if I want to calculate the first derivative, then formula for first derivative will be, okay, we are going to use this particular formula. So first step will be replace this t by upper limit x. So you will get e to the power minus x square by 2, right? Then derivative of this upper limit, so this will be 1 minus lower limit is constant, derivative will be 0. So this will be f dash x. Okay, the expression for f dash x is e to the power minus x square by 2. Now second derivative will be e to the power minus x square by 2 into derivative of minus x square by 2 with respect to x. So this will give us minus 2x by 2. Finally you will get minus x e to the power minus x square by 2. So now we need to compute first second derivative at x equals to 0. So this will be minus, now since this term is multiplied by x, if I place x equals to 0, I'll get 0. This will give us 0, this is 1, the product will be 0. So since the second derivative at 0 is 0, a2 will be 0 by 2 factorial, which is 0. So the correct answer will be the coefficient a2 is equal to 0. So these were two problems on Taylor series. Now next we will talk about partial derivatives.